Welcome to Lecture 0102 titled Setting Up GitHub for HDL Projects and Colab Notebooks. In this session, we will establish the foundational infrastructure needed to manage your HDL development work throughout the course. We will be working extensively on Google Colab to write, simulate, and test Verilog and VHDL code using AI tools like ChatGPT and Gemini. However, to persist our work, share our progress, and create a professional project portfolio, we will use GitHub. GitHub is a cloud-based version control platform trusted by millions of developers across the world. In the context of this course, it will function as your personal HDL project, space a structured environment, where your AI-generated notebooks, HDL files, test benches, and documentation can be safely stored and showcased. By the end of this lecture, you will have created your own GitHub account, initialized a new repository, written a clear README using markdown, and created a dedicated branch called Colab for storing your Jupyter notebooks. Today's featured tool is GitHub. GitHub serves as a powerful cloud-based version control system where you can store code, notebooks, AI-generated outputs, and documentation in a structured manner. For HDL learners and designers, GitHub offers the ability to build a real-time version portfolio of all project assets. Let's review its key benefits. First, it is free and universally accessible via any web browser. Second, it enables collaboration with peers or instructors without the need to exchange files over email. Third, it maintains a complete history of your changes, allowing you to track your learning progress over time. In this course, you will use GitHub primarily to upload IPYNB files created in Google Colab, organize HDL design files, and store documentation including waveform diagrams and simulation outputs. You will also be able to share your GitHub link in your resume or academic portfolio, making it an integral part of your learning journey and professional development. The core objective of this lecture is to prepare your GitHub workspace so that it can function as a long-term portfolio and a real-time working environment. In order to do this, we will walk through three key tasks. First, you will create a GitHub account if you don't already have one. Second, you will set up a new repository, which will serve as your central hub for all course-related materials. Third, you will learn how to use Markdown to edit your README file. This is your repository's landing page, and it should describe your goals and contents clearly. Finally, you will create a separate branch called Colab where all your simulation notebooks from Google Colab will be saved. By completing these steps, you ensure that your work is organized, well-documented, and backed up in a version control system that is widely accepted across the software and hardware design industries. To support your understanding, AI tools like ChatGPT or Gemini can be used to provide step-by-step explanations. Here is an example prompt. You can try, explain step-by-step how to create a GitHub repository, write a README file in Markdown, and create a new branch named Colab. Assume I am a beginner. This prompt is designed to help you reinforce what you're learning in this lecture. The AI will likely guide you through creating an account, logging in, initializing a repository, editing files using Markdown, and managing branches. It can also explain important concepts such as what a README file should include, how Markdown formatting works, and how branches help in versioning and organizing different types of files within a project. This prompt-first learning model makes the process highly interactive, allowing you to clarify doubts immediately, receive customized examples, and even auto-generate content you can copy and edit into your GitHub repository. Let's now go through the first major step: creating your GitHub account. In our last lecture, we already discussed how to create an account on GitHub. If you haven't logged out of your account after creating it, clicking on the GitHub link will automatically log you in. Just as a recap, begin by visiting https://github.com, https://github.com. Click on the Sign Up button. You will be prompted to enter your email address, a username, and a strong password. After submission, GitHub will send you a verification email. Once you confirm your email address, complete the onboarding form. You may skip any unnecessary steps, such as choosing a paid plan or subscribing to newsletters. By the end of this step, you should have access to your GitHub dashboard. It is highly recommended that you choose a professional username, one that you can include in your resume or LinkedIn profile. GitHub usernames are permanent, so choose wisely. Once your account is created, you will be ready to start hosting your HDL code, Colab notebooks, and documentation, all of which will form your AI-powered HDL portfolio. The second major step is to create a new GitHub repository. After logging in, click on the plus icon in the top right corner and choose New Repository. Enter a repository name, for example, AI_for_DLD_Udemy. Add a clear and concise description, such as AI Augmented HDL projects and notebooks. Be sure to check the box that says Add a README file so your repository is initialized with a home page. Set the repository visibility to public so that others can view and evaluate your work, especially when sharing your profile with recruiters or instructors. Finally, click Create Repository. This will take you to the main repository page, where you will see your files and branches. From here, you can start adding HDL files, simulation results, or structured notebooks. Remember, this repository is the central hub for everything you will build in this course. It should be updated regularly and maintained professionally. Once your repository is set up, the next task is to edit the README file. On the repository homepage, locate the file named _README.md and click on it. You will see a pencil icon on the top right. This is the Edit button. Click it to open the editor. Replace the default text with a clean markdown description that gives a complete overview of your coursework. A sample structure may include a project title, a brief introduction, and a folder structure. For instance, your repository might have Colab for notebooks, HDL, for Verilog or VHDL files, and docs for waveform diagrams and documentation. Markdown allows you to format content using simple syntax, like # for headings, or ** for bullet points. After editing the file, scroll down and click Commit Changes. The README now becomes the professional front page of your HDL portfolio, accessible by anyone who visits your GitHub repository. Now let's create a dedicated branch named Colab. Branches in GitHub allow you to manage different sets of files or workstreams within a single repository. To create the Colab branch, go to your repository homepage and find the branch selector near the top left corner of the screen. It usually displays main by default. Click on it, type Colab and press Enter. GitHub will immediately create a new branch with that name. This Colab branch will specifically be used to store all notebooks generated during your simulation work in Google Colab. By separating simulation notebooks from documentation and HDL code, you maintain a clean structure and make it easier for others to navigate your work. As you move forward in this course, you'll be saving IPYNB files directly to this branch using AI-assisted scripts and the GitHub API. This step ensures your work is organized, searchable, and easy to track. To deepen your understanding of branches, here's another helpful prompt you can try in ChatGPT or Gemini. Explain what GitHub branches are and how to create and use a new branch named Colab for storing notebooks. This kind of question allows AI to give you conceptual clarity as well as practical, step-by-step instructions. You will learn that branches help isolate different workflows, such as development, documentation, and testing, within the same project. For example, you might later create a docs branch for writing detailed reports, or a testing branch for trying experimental logic. But for this course, the primary division is between the main branch, where your HDL files and documentation reside, and the Colab branch, where your simulation notebooks are stored. This division ensures that each file type is in its appropriate place, making collaboration and file tracking more efficient and professional. As we conclude this lecture, let us briefly summarize what you have achieved. You have successfully created a GitHub account, initialized a repository named AI_for_DLD_Udemy, written a professional README file using Markdown, and created a new branch named Colab specifically for simulation notebooks. This setup prepares you for the next stage of the course, where you will begin using Google Colab to install simulation tools such as GHDL, Verilog, and Yosys using AI-generated shell scripts. These tools will be used to simulate HDL code and analyze waveform outputs. From the next lecture onward, your workflow will include saving backcoat IPYNB backcoat files to GitHub, enabling version control and backup for every practical you complete. Before proceeding, please bookmark your repository, secure your GitHub login credentials, and ensure you are comfortable navigating the GitHub interface. In the next session, we move from setup to execution, installing tools, and simulating your very first digital logic circuit.